So let's start your thermodynamic snap. And as you mentioned, you are preparing for your OL India Limited interview.
Yes, sir.
So last year you appeared for exam, written examination, and you qualified that written exam, and now you received call for the interview.
Yes, sir.
Good. So Adil, what is thermodynamics?
So thermodynamics is a branch of science that deals with system in equilibrium. It tells how much energy is a system from one thermodynamic state to another thermodynamic state. It deals about ये बताता है कि कितना एनर्जी हम लोग को लगेगा. इसको कोई रेट से मतलब नहीं कि किस रेट पे ट्रांसफॉर्मेशन होगा, ये बस क्वांटिटी, हाउ मच हीट इज रिक्वायर्ड.
So how we can define a system? Acha, can you give me like suppose if I give you an example of a pressure cooker, what do you feel? Pressure cooker is a kind of what type of system?
So in pressure cooker, it is a closed system because only energy in the form of heat can be exchanged, but there is no transfer of mass. इसमें कोई भी mass बाहर in और out नहीं हो रहा है, बस energy entry दे सकते हैं, इसलिए ये closed system है.
Closed system है. Fine. And suppose you are having some kind of water inside that pressure cooker.
Yes, sir.
And you are producing steam. You are heating that water content. Yes. You are producing steam. Okay. Now tell me how and with which you can approximate this process, heating process.
Yes, sir.
Like suppose if you want to carry out any kind of thermodynamic analysis on that pressure cooker closed system, so what do you feel? That heat addition process, we can approximate it as a, considering it as a kind of what kind of process? Constant volume, constant pressure?
Isochoric. Since pressure vessel is a rigid vessel, so we can assume it to be isochoric.
But there is some kind of petcoke is there at the top of the pressure cooker, and steam can leave out of that petcoke.
Yes, sir. Beyond certain pressure, steam can leave.
But so how you can say it is a constant volume?
सर वो उसका वेसल जो होता है बहुत रिजिड होता है, वेसल का वॉल्यूम चेंज नहीं होगा, बहुत एक्सटेंट तक वो कांस्टेंट वॉल्यूम ही रहेगा. प्रेशर उसके अंदर वैरी करेगा, धीरे धीरे बढ़ना शुरू होगा, फिर एक लिमिट के बाद प्रेशर रिलीज हो जाएगा.
So can you draw the PT curve for water? Pressure temperature curve अगर मैं आपसे पूछूं water के लिए, can you draw?
Yes, sir. Sir, may I use my pen?
Yes.
Yes, sir.
Which one is the sublimation curve?
The sublimation, here so solid is going into vapor. If we name it A, B, C, D, A, B, so this one is sublimation curve, solid into vapor.
Can we have a vapor if you are having the temperature below the critical point temperature? Sorry, below the triple point temperature. So if you are having the liquid water at a temperature below critical point temperature, so can we have vapor below that?
Below critical point temperature?
Yes.
Sir, yes, sir, we can have that.
Below critical point temperature, we can have vapor.
Sir, yes, sir, I think we can have it.
And what about liquid?
Sir, we can have liquid below critical temperature.
And suppose if you are having liquid below critical point pressure?
Yes, sir. Sir, no, it is not below critical point pressure. Liquid cannot be there. Vapor, liquid cannot. Yes, sir. Below critical.
What is that triple point? Sorry, I mentioned critical point. It is actually triple point. So what is the triple point for water?
The triple point, sir, it is 0.01 degrees C, 273.16 Kelvin.
And what is triple point pressure, Adil?
Sir, 0.61 kilopascal.
0.61 kilopascal.
Yes, sir.
And which equation, like on that PT curve, suppose if you want to find out the saturation pressure, Adil,
Yes,
so
sir.
in thermodynamics, can you tell me which equation we use to find out the P saturation, vapor pressure, or P saturation corresponding to a particular T saturation? You know, pressure,
Sir,
temperature, they are function of each other. They are directly proportional,
yes,
not
sir.
linearly, but they are directly proportional. Because
Yes,
if pressure increases, temperature also increases.
yes, sir.
So what do you feel like? By which equation we can relate those P saturation and T saturation in thermodynamics?
Sir, I cannot remember that name, but in thermodynamic relation, we have studied that.
Equation.
Yes, sir. ln P by T saturated, HFG by T mu square. Sorry, sir,
So
I cannot recall
what are
that.
those thermodynamic relations? Adil, can you write some
Yes,
of the
sir.
thermodynamic relations?
Yes, sir.
Go ahead.
The fourth thermodynamics equation.
Uh,
TV. And temperature at constant pressure. Yes, sir. This.
okay.
Yes.
Adil, what is second law of thermodynamics?
The second law talks about quality, direction, spontaneity, and feasibility. Basically, second law was given by two scientists. They are Kelvin statement and Clausius statement. Kelvin said that it is impossible to construct a device working on a cycle which produce continuous work while interacting with single thermal reservoir. And Clausius also said that it is impossible to transfer heat from lower temperature to higher temperature without consuming any external form of work.
What is the difference between a heat pump and refrigerator, Adil? Heat pump में और refrigerator में क्या difference है?
सर हीट पंप जो होता है वो हीट लेता है from a source of which is higher temperature to produce work. Whereas रेफ्रिजरेटर क्या करता है, वो लोअर टेम्परेचर से हायर टेम्परेचर की तरफ हीट को ट्रांसफर करता है बाय कंज्यूमिंग सम फॉर्म ऑफ वर्क. रेफ्रिजरेटर वर्क लेता है और स्टीम टरबाइन वर्क देता है.
So how you can write the second law efficiency for a heat pump? एक heat pump के लिए कैसे आप second law efficiency लिख सकते हो?
COP. So COP of
No, second law efficiency. I'm asking you second law.
the second law efficiency of heat pump. Sir,
Yes.
It is actual COP that is given divided by COP that is given by reversible heat pump. जो actual दे रहा है divided by when the pump was doing heating effect.
Adil, how you are going to check the feasibility of a device like thermodynamic device? Like suppose if I will give you a heat pump, how you will check its feasibility, whether that kind of heat pump is feasible or not?
Sir, its efficiency should be less than maximum possible efficiency. The maximum efficiency we can find it when all the systems are reversible.
So what is the range of efficiency, Adil, for a heat pump? What is the maximum efficiency that we can get for a heat pump?
Maximum, sorry sir, I have no idea about that.
And what is the maximum efficiency for a refrigerator?
Sir, I have studied COP of that.
COP, yes, COP only, Adil. What do you feel? What is the maximum COP for a heat pump and refrigerator?
Maximum COP. So it depends upon temperature limit. CO temperature limit से decide कर सकते हैं. So minimum COP of heat pump can be 1, but I don't know about maximum.
ठीक है. Adil, can you tell me something about free expansion? What is free expansion?
The free expansion, in free expansion, sir, gas expand करता है and in vacuum. No, there is no work done. कोई भी work नहीं करता है क्योंकि किसी के against वो काम नहीं कर रहा है, and there is no temperature change, energy change. So मतलब without restriction it is passing, expanding. It is called free expansion.
So what do you feel? Free expansion is a kind of isothermal process?
The free expansion, sir, cooling effect होती है इसमें.
Cooling होता है, temperature decrease करता है.
Throttling की वजह से sir temperature decrease करता है.
No, free expansion. I'm talking about free expansion.
Sir, इसमें शायद नहीं होना चाहिए.
क्या नहीं? Temperature is going to increase, decrease or remain constant?
Sir, temperature पहले decrease होती है, फिर normal हो जाती है, मतलब constant रहती है.
So how you are going to calculate the entropy generation in free expansion?
So entropy generation.
Free expansion में entropy generation कैसे calculate करोगे?
Sir, change in volume sir calculate कर लेंगे. Temperature तो constant है, लेकिन change in volume ही होगा. तो बस ln V2 by V1 कर देंगे.
Pressure change नहीं होगा?
सर अगर टेम्परेचर के रेस्पेक्ट में मानेंगे तो प्रेशर भी कम होगा, लेकिन खाली टेम्परेचर CV ln T2 by T1 प्लस R ln V2 by V1, T2 by T1 तो 1 हो जाएगा, 0 हो जाएगा. खाली वॉल्यूम को चेंज कर लेंगे. Change in volumes.
Well, you heard about continuum concept.
Yes, sir.
What is the need of continuum concept in thermodynamics?
The continuum use, sir, continuum is done by taking average behavior of particles. इसमें एवरेज बिहेवियर लाते हैं और इसके लिए 4 कंडीशन सेटिस्फाई करना होता है सिस्टम को. कंटिन्यूम के लिए कंटिन्यूअस होना चाहिए, यूनिफॉर्म होना चाहिए, नो वॉइड्स होना चाहिए, लार्ज नंबर ऑफ मॉलिक्यूल्स होना चाहिए, और हुंड्स नंबर लैम्डा बाय एल should be less than.
कंटिन्यूम का जरूरत क्या है दिल? What is the requirement?
Sir, continuum में sir
some matter you are having which is not uniformly distributed.
Yes, sir.
So what it means, like you cannot carry out thermodynamic analysis for that kind of system where the matter is not uniformly distributed.
उस पे भी कर सकते हैं. तो मतलब मैक्सिमम चीज को कंटिन्यूम
दोनों की थर्मोडायनामिक एनालिसिस में व्हाट इज द डिफरेंस?
सर कंटिन्यूम और इसमें कंटिन्यूम में सर.
यस, कंटिन्यूम एंड विदाउट कंटिन्यूम.
सर विदाउट कंटिन्यूम सर वो उसके लिए यूज करते हैं कि बहुत दूर होना चाहिए, जैसे स्पेस एक्सप्लोरेशन, रेरिफाइड गैस थ्योरी, हाई वैक्यूम. इस कंडीशन में हम लोग दूसरे वाले को यूज करेंगे, लेकिन कंटिन्यूम ऑलमोस्ट हर जगह यूज कर सकते हैं.
My last question is to Adil. What is entropy, and what is the difference between entropy and entropy generation?
So entropy is the randomness or disorderness associated with the body. Entropy एक particular system की होती है, लेकिन entropy generation की जब बात आती है तो पूरा यूनिवर्स को हम काउंट करते हैं. तो एंट्रोपी जनरेशन के लिए हम पूरा यूनिवर्स को काउंट करते हैं, और इसमें इसको भी अकाउंट में लेते हैं कि कितना हीट ट्रांसफर हुआ फ्रॉम सिस्टम टू सराउंडिंग, कितना हीट इंटरेक्शन कर रहा है. एंट्रोपी जनरेशन इज अबाउट होल यूनिवर्स एंड एंट्रोपी इज रिगार्डिंग पर्टिकुलर सिस्टम. एंट्रोपी कैन बी पॉजिटिव, नेगेटिव और जीरो, whereas entropy generation is always positive.
Positive, negative or zero for what? Like system or surrounding?
The entropy generation For a process, entropy can be positive, negative, or zero. For universe, always for universe, entropy generation is taken.
Adil, what is availability?
Sir, availability is the maximum work that can be obtained when the system reaches from its original state to its dead state. जितना मैक्सिमम वर्क निकाल सकते हम लोग यूज कर सकते हैं जब सिस्टम अपने डेड स्टेट पे आएगी उसको अवेलेबिलिटी कहते हैं.
ठीक है Adil, let me provide you the feedback. So I started with what is thermodynamics. You mentioned about some use, system surrounding. Actually, when interview is asking about thermodynamics, so you need to mention, you need to highlight about the application part. You need not to define system or all those things.
Yes, sir.
What is the application? What is the need of studying this subject, other thermodynamics? That you need to highlight.
Yes, sir.
Some application part.
Sir,
So I pressure cooker. What do you feel? It is a kind of what type of system? So you mentioned that was right. Closed system ho jayega. And yes, initially the heating process will follow a kind of constant volume process, constant volume heat addition. And after reaching to some kind of pressure cooker maximum pressure, the process will be like a constant pressure process. Second law, don't mention it like a law given by two scientists.
Yes, sir.
It's not like that. It's a combined effort of lots of other researchers, scientists.
Yes, sir.
And it is not like that for second law of thermodynamics you are having only clauses and Calvin statements.
Yes, sir.
There's so many other statements also.
Yes, sir. Yes, sir.
So you can mention about Ostwald statement. Okay, there is some kind of PMM2 also you can mention. PMM2 efficiency will always be less than 100. PMM2 is impossible. 100% efficiency is impossible.
Yes,
entropy of the universe keeps on increasing. For
yes,
an isolated system, entropy change will always be greater than equal to 0. These things
yes,
are not there in Calvin Planck's and Clausius statement.
Yes, sir. Sir.
Second law efficiency for heat pump you mentioned, that was right. That is actual COP by maximum COP, means reversible COP. Heat pump ka maximum efficiency can be infinite. It depends on the temperature limit, but it will be less than infinite, greater than infinite. It will be in that range only, 1 to infinite. Less than infinity, greater than 1.
Yes,
not
sir.
1. Minimum 1 nahi ho sakta.
Yes,
heat
sir.
pump ka efficiency will always be greater than 1.
Greater than 1. Yes, sir.
Availability you answered, that was right. Entropy generation, that difference was also right. So Adil, overall technically मैंने इससे पहले भी interact किया, and
yes, sir.
Technically there is no such major difficulty. You are answering to the question.
Yes, sir.
But you know your delivery style you need to improve.
Yes.
थोड़ा सा मेरे को जो लगता है कि जिस तरह का जो एक kind of what you can say
रुक के होता है सर, प्रैक्टिस करते करते मतलब लास्ट तक सर इम्प्रूव कर जाता है, इसीलिए थोड़ा.
Actually very honest person Adil.
Yes, sir.
Last like when you appeared for the interview last year, you mentioned about that HPCL interview. You know, I interacted with you and I got idea like you mentioned about sir, my interview got very well.
Yes.
But you
yes,
know,
sir.
people actually they want a kind of person who is not telling like it is not very much required to tell each and everything clearly. Like you know, honest hona chahiye. It is
Yes,
not
sir.
to be honest person.
Yes,
but
sir.
honest ke साथ साथ like suppose every single thing which are not required behavior wise, what you can say, which are related to your life, those things you need not to tell.
Yes, sir.
So you are a very honest person, but you know in industry people sometimes
yes, sir.
different perspective. Okay, it is not like that ki I want that kind of person or some other person. It depends. Okay?
Yes, sir.
But in general, what I can say, people want some kind of person who is very much strong, who is having some kind of leadership quality, some kind of smartness in dealing or in communicating with other persons.
Yes, sir.
So those things I think you are lagging somewhere.
Yes.
तो आप बहुत polite हो, it's a good thing, but you know those things also little bit you need to improve.
Yeah.
So some some kind of what you can say all different skills, personality skills. Okay, those are part, and you need to have a little bit of each and everything.
Yes sir. So लेकिन आएगा कैसे सर ये सर?
आ जाएगा अभी करते रहो, प्रैक्टिस करते रहो, लिसन योर रिकॉर्डेड सेशंस, जो इतने भी आपने मॉक दिए हैं आदिल, try to explore and try to get idea, some idea like where you are lagging, and you need to improve all those things.
Yes sir.
थोड़ा सा वो मेच्योरिटी जो है वो लगना चाहिए ना, like in interviewer, suppose if interviewer is asking you how your interview goes well,
yes
so people can say like अब वहां पे आपको थोड़ा सा एक उसको different way में आंसर करना है. It is not like that कि you are confident enough, you are confident, okay,
yes,
but if you say sir my interview goes very well, this time also, like suppose if I will ask you how was your interview, what do you feel, how much, how what do you feel, like how many marks you are going to give to yourself, okay, so I'm 100, I know like you are going to say sir 9 marks, 10 marks,
yes,
so you are confident, it's fine, but you know sometime you need to highlight, sir what I feel I performed well, and I'm a hardworking candidate, I'm a strong I'm having strong conceptual background, so I can give myself 8 marks, close to 8 or 9 also you can highlight, you can say 10 also, but before mentioning that 10 you need to make a kind of, you know, some kind of statement.
मॉल बना देना है.
हाँ, डायरेक्टली अगर आप कहोगे कि सर 10 नंबर, ऐसा तो वो नेगेटिव रहेगा. Regarding Adil,
yes sir,
so before mentioning 10 or 9 you need to frame, you need to mention some lines.
Yes sir.
Like why you want to give 10 marks to yourself?
Yes sir.
You need to justify that also. So those things like in GD or any interview when you are going, before mentioning anything you need to think for a while, and then only you need to answer. Technically there is no such problem, Adil.
Yes sir.
Earlier also I mentioned.
Yes sir.
So keep improving all those things. Okay, in detail we will discuss.
Yes sir.
Tomorrow or day after tomorrow just WhatsApp me, we will discuss in detail.
Yes. Okay.
Good luck and keep preparing.
Thank you sir.
Okay.